Okay, let's do one of these now, where we're launched off of a cliff with no angle. So I'm not going to bother writing out the question. I'm just going to have this thing launched off here. It's going to travel straight out, but gravity's going to pull it down. This is going to be your range. I'm going to tell you that the height of the cliff is going to be 80 meters, and I'm going to tell you that your initial velocity, or your velocity in general in the x direction, is 30 meters per second. Okay, that's what you know. Well, I guess you know a few things. Well, if we draw the object at its bottom portion here, we know that that thing still has an x velocity of 30 meters per second. We want to find, this is what I want you to find. Time to the ground. And that's 1. I want you to find range of flight. That's 2. And I want you to find the velocity at impact. So this isn't V, this is like VR. Or sorry, this isn't VF, I mean. This is your resultant velocity. This is Vx, we want to find Vy, and then we want to find the resultant and figure out what it is over there. We want to find the time to do this, and we want to find the range of flight. So those are all the things we want, and we know that it's 80 meters to do it. So let's see here. First, always first, we want to find Vx. Well, we know Vx is 30, and we know Viy is 0 meters per second. Falls straight down. That's Vy, but it starts off at 0. So I know that this thing is 80. So what I'd like to do is I'd like to find my time to hit the ground. So that's going to be my second point. I'm going to put it here. I'm going to find t, time to ground. So I'm going to go dy equals vit plus 1/2 at squared. This is all in the y direction. dy, I'm going to make a purposeful mistake here. By putting 80 here, I've screwed up on purpose. My viy, we already know that's 0. Time I'd like to find, 1/2 acceleration, that's gravity, it's -10 all the time, t squared. You know that this thing goes away. This thing is 80 minus 5 t squared. So when I solve this thing for t, I'm going to get the square root of 80 divided by -5. Well, when you plug that into your calculator, 80 divided by a minus, that's just going to mess you up. You can't take the square root of a negative. So here's where I said I made my purposeful mistake. Go back to this. Look at here's your object. Your object goes from a positive area and it goes downward. That means that this direction it falls is actually negative, which means this should have been a negative, that should have been a negative, which means that should be a negative. Negative over negative cancels off, and you're able to get your time as 4 seconds. Okay, so that's the time to the ground. Time to ground. Okay, so that's first part. Now we want to find the range of flight. So that's third. So we want to find range. That, in this kind of question, is fairly straightforward. You have constant velocity in the x direction, and range typically is, well, it is always dx. So dx equals vixt plus 1/2 at squared. Well, there is no acceleration in the x direction. There's only acceleration in the y direction, so this whole thing goes away to 0. So we're just left with d equals vixt, and we know that the initial velocity is the same as everywhere, so it's going to be 30. So my range, my dx, is going to be 30 times this time that I just found, 4. So my dx is going to end up being 120 meters. Okay, so that's my range. That's that. Now, I wonder if we have enough room here for my fourth point. Fourth, we want to find the impact velocity. Okay, bind impact velocity. This one, slightly more tricky. What we need to do is essentially, in the end, this is what I'd like to show. I'd like to show that Vx is this. I'd like to find my Vy, the final y. Okay, so I'll have a Vx and a Vy. I'll want to find this. That'll be my resultant velocity. That's my impact velocity. And this is the angle that it hits with. So I'm going to go V at whatever theta value that is. So I have Vx, that's 30. What I need is my V final in the y direction. So I'm going to use, to find that Vf, I'm going to go Vfy equals Viy plus At. Vfy, Viy is 0, that goes away. Gravity is minus 10. Time to fall is 4. So my final velocity in the y direction is minus 40 meters per second. Minus 40 meters per second, okay? That is right here. Minus 40 meters per second. You can see that I would slide this over, so this would go here, and that's going to be that impact velocity that I'm trying to find right there. Right angle triangle right there. So my VR is going to be the square root of 30 squared plus minus 40 squared. In the end, your VR ends up equaling 50 meters per second. It's like a 3, 4, 5 triangle. So that's 50 meters per second at, and we want to find that angle. Almost out of room here. Opposite over adjacent, that's tangent. Tangent of theta is opposite, 40. Adjacent is 30. Your theta value ends up equaling 53 degrees. So that's going to end up being 53 degrees, and I'm out of room, so I'll have to write the fact that this thing is south of east right there. There you go. That was a lot of work for horizontal off of a cliff, no angle, but there is absolutely no other question that I could ask you other than something strange like about the object being right there, which could happen, but that's just, again, you're just going to use one of your 4 equations wherever I wrote them. You can use that one or one of the other 3. Okay, there you go.